Welcome everyone to a computer history moment. 20 years ago, actually AMD released the first version of 64-bit x86 processors. First AMD 64 Opteron Sledgehammer released April 2003. That fast is how time flies. I want to take the moment to go some 10-15 years over this history that many newcomers to computing, to modern gaming and Linux probably don't even know. Because one thing is AMD 64, back in that day, of course, Intel was dominating the PC market, but x86 was far from the dominant player in professional computing. Certainly pretty unthinkable today. 20 years ago, computing was mostly like professional computing, servers, mainframes, and supercomputers were actually dominated by brands like IBM, PowerPC, Sun, Spark, SGI MIPS, Hewlett-Packard precision architecture, and even other stuff today unthinkable like NEC, vector engine, and also former supercomputer giants like Cray. So 20 years ago, what is today, also if for those new, AMD 64 is actually what Intel is also using today, and Intel was actually pretty late to the party. Because 64-bit computing was not even that new, it all started much earlier. The first 64-bit processor volume for the general public and availability was actually released in 1991 by no other than MIPS Technologies, company responsible for the first RISC architecture, the R4000. Produced the first commercially available 64-bit processor, was initially used in SGI graphics workstations, previous video, SG Octane, O2, of course later generations, and run a 64-bit version of the RISC operating system. Then in somewhat that order, there was also a highly popular and highly performant DEC Alpha EV4 product number 21064, released in 1992 with 100 to 200 megahertz with a 0.75 micron process. Motorola Incorporated and IBM were also there at that time, already announced their first 64-bit PowerPC processor, the 620. First silicon expected to the general public unsampling the second quarter of 1995, and the chip was initially running at 133 megahertz and as usual later maximum clock speed design of 150 or so megahertz. Also, as seen here, very popular Sun Spark version 9 instructions and architecture specification, released already as early as 1993, introducing 64-bit architecture to Spark and the first Ultra Spark, previous video processor, released in 1995. Hewlett-Packard, of all computing companies, was also there at that party, extending their Hewlett-Packard precision architecture to 64-bit in 1996 with instruction set architecture revision named PA, Precision Architecture RISC 2.0. That were probably one, if I forgot one of the other many 64-bit processors, leave them in the comments below. And Intel, of course, wanting more of this top 500 supercomputer, professional networking and server market share. And similar to myself, not very satisfied with their complex instruction architecture, inherited from their 4004, 8008, 8085 or so, 8086, with then 8-bit, 16-bit, 286, 386, very convoluted and hard to scale architecture. So Intel did, of course, what they already previously tried, and getting rid of x86, also with then the clones and better profit and market share. So they actually, together with Hewlett-Packard, created the Itanium architecture that should run circles around classic x86 as we all know it. Itanium architecture actually originated at Hewlett-Packard with their PA precision architecture RISC business and was then jointly developed by Hewlett-Packard and Intel. Launched in June 2001, and initial Intel marketed the processor for enterprise servers and high-performance computing systems. We all know how that went. The initial optimistic quotes were, we could run circles around PowerPC, that we could kill the x86. Now that went as usual as IT projects go. IA64, as it is usually abbreviated, actually used 128-bit instructions in bundles of 3, which were notoriously hard to scale in hardware and even harder to highly optimize with compiler technology 20 years ago. AMD, of course, could not just copy IA64 Itanium due to patents and all the other stuff like they could with the second sourcing of x86 that they have actually officially done since the end of the 70s or so, and thus did what clever engineering would do and simply extend the convoluted, complex instruction set architecture of this x86 to 64-bit. Probably initially laughed at Microsoft and Intel and all the other top 500 supercomputer companies as cheap technical hack to extend x86, the beating the dead horse that is and was x86 apparently, even further, and named that AMD 64, as some people still today. So came the AMD 64 x86 16-bit or 32-bit and then a new 64-bit variant compatible Opteron with a Sledgehammer core, and thus AMD invented the 64-bit extension of x86. Created alternatively radically different to the IA64-bit architecture, being 128-bit bundles, and AMD 64, of course, just being yet another extension of the classic vintage 8086 architecture. Thus totally incompatible with IA64, obviously, and also to make use of the 64-bit, of course, operating system had to be adapted, as was Windows and Linux, and later the BSDs, and eventually even macOS. Being fully backward compatible, of course, you could boot DOS or Windows 1, 2, 3, 95, and later the 64-bit ports. AMD originally announced AMD 64 as early as 1999, with the full specification available in August 2000. And AMD processors implemented the AMD 64-bit architecture since then, first including the Opterons, then Athlon 64, 64X2, 64FX, Athlon 2, followed by X2, X3, X4, indicating the north course, and all the processors since then. Intel, of course, with their power-hungry, not scaling, and totally incompatible Itanium architecture, did what a Plan B company would do. They would actually develop a clone, top secret, of the AMD 64-bit architecture, allegedly internally named Yamhill, I believe. No, I lost my notes here. And apparently the first processor implementing 64-bit was the Pentium 4 branded Prescott 90 nanometer as late as February 2004, and but that feature was disabled. So if you have other Intel knowledge, Intel employee and stuff, leave in the comments below. Intel subsequently began selling 64-bit Pentium 4s with zero stepping to OEMs with the execute disabled bit support, which was one additional memory management feature that AMD brought with their AMD 64 implementation, and Intel's first official Intel 64, because obviously they didn't want to ship their stuff named AMD 64, inventing a new incompatible marketing name, EM64T at that time, but who calls it EMT for extended memory 64-bit technology? Of course, mainstream calls it either x86-64, AMD 64, or just Intel 64 if someone is not really that much into all this proprietary convoluted naming. Of course, since then, except the initial Core Solo or so, but then Core 2, or actually not Core Solo, but any core, initial core, ironically, the initial core processor that Apple used in their first MacBooks did not support that yet, and that only came with the Core 2, and then since then, of course, all Intel Core variants until the 13th generation now support that 64-bit execution mode that we all still run until today. Of course, ironically, today's epic thread ripping. Since then, it was a hard battle between Intel and AMD, certainly with some unfair marketing shenanigans there, lots of dirty money, and Intel math library and compiler lawsuits were fought and lost by Intel, manipulating the market of making AMD CPUs at times slower than they actually were, and so on. And of course, with Intel, with initial AMD Opterons having a very high server market share with this x86 64-bit extension, of course, due to Intel's marketing and technical practices, they certainly kept the dominance there. And because actually initially AMD CPUs were actually faster than Intel's until core variants and AMD's less than stellar bulldozer also projects. But of course, in latest years, thankfully, AMD bringing competitive epic thread ripping Ryzen from the ashes performance back to this now highly competitive market again to actually innovate much faster, because obviously, as we all know, the only substitute for performance is more performance and obviously more bits. That basically is a very fast summary that I compiled today. Let's see also, where did I leave my YouTube? There. I hope you enjoyed this summary and learned something. Slightly wondering why we don't have more people tuning in. Not sure what's going on with that. One personal note, I personally did not even take that too seriously, because back in the day I already had 64-bit computing. Namely, my first was in Sun Ultra Spark 5 with an Ultra Spark 2E or so. And my second 64-bit processor was then probably also eventually some IBM PowerPC. I personally didn't take that too seriously because I, like many other professionals, thought AMD's proprietary extension didn't have any chance on the market. And so with our Rock Linux back in the day of our T2 Linux distribution nowadays, didn't even personally work on that port that I would of course use nowadays, and basically let other Rock Linux developers do that, because there was not really much for me to gain, as I had 64-bit Ultra Spark, PowerPC, MIPS, and it was for me as much as a surprise as many other professionals that AMD 64 x86 architecture actually became as dominant as it is today. I did not expect that. Certainly, there also the Itanium certainly quite significantly influenced the market of everyone betting on the success of Itanium, and thus MIPS Technologies ending their own MIPS and SGI ending their own MIPS processes, and actually also sourcing IS64. Actually, the last SGI computers were also based on Itaniums, and certainly Hewlett-Packard ending their own Hewlett-Packard precision architecture RISC in favor of their, nowadays we know, misguided and failed EPIC Itanium processor. And with this, players, of course, Sun and IBM continuing, but their systems certainly good, but power hungry and relatively pricey. I also have to say the SPARC performance left a lot to be desired. Of course, after the Ultra SPARCs, we had the T1, 2 and variants, Niagara Falls, Cool Thread projects from Sun, but they certainly had many threads and run cool, but their relative performance for IPC instructions per clock certainly left a lot of to be desired, which unfortunately is why even Sun's successor at Oracle nowadays, the SPARC line pretty dead, and mostly leaving, of course, then the ARM, which is not even in this history, ARM not mentioned once because they were never at the forefront of high-performance computing, only in embedded and mobile space. And certainly IBM PowerPCs are only left standing, but only in relatively pricey IBM systems. Certainly performance per watt also not the most competitive. And then the now new RISC-V. All the other architectures, as much as I love to maintain them in our T2 Linux, from even Super H, MIPS and SPARC PowerPC, just also for the iconic systems with their design, with their much more reliable firmware or professional firmware, not quirky PC BIOSes. But yeah, the market certainly totally changed, and it will be interesting to see where we will be in 10 and 20 years. Certainly ARM has a very big role to play now that they are also 64-bit since less than a decade or so. But then also RISC-V, but that certainly takes a while. I personally bet hugely on RISC-V as they are a royalty-free instruction set architecture. But that is of course to be seen whether ARM can, with Apple Silicon, gain more momentum. But I personally bet on lots of entry-level and mid-performance future will be RISC-V, simply because it is open source and royalty free. And x86, I would be surprised if x86 remains to be as dominant. I would personally expect x86 that this year or this year's, we will see how my prediction stands, but this year's being the peak x86. From now on, it is probably only more ARM64 for less complex instruction set architecture, better performance per watt, and saner, less history, compatibility, legacy, convoluted, do I need to say 820 gate, but other 16-bit mode complexity still in the core, and potentially better scaling in the future. And then certainly not in the near term, because it takes just so long for all these new RISC-V companies to re-implement everything from superscalar and speculative execution for such high IPC throughput as we see these days from EPIC thread-ripping AMD Ryzen. So that's certainly easily 5, if not 10 years in the future for RISC-V to reach a similar peak performance. But I would guess, or I would predict, this is peak x86 evolution, and from then, don't forget to subscribe. Let's compare in 10 and 20 years where the CPU market is standing. It's certainly a crazy ride with all this previous instruction set architectures. It was a crazy ride, and certainly this also shows that not always the best technical solution wins, because I would certainly say that PowerPC, maybe not necessarily MIPS, my personal rating would probably somewhere like PowerPC, one of the better implementations. SPARC also mostly accepts the register window. MIPS certainly has some limitations that could, however, be fixed, and the latest MIPS 64 or MIPS 32 R6 also certainly fixed some shortcomings. Also Spark with a delay slot that actually Oracle added, I believe, delay slot less branches with their last or second last generation of silicon, I believe M1 or what that was. So not even my Sun T4 does not have this delay slot. These are extreme tiny implementation details that, however, make scaling and speculative superscalar executing an instruction architecture just a little bit more inconvenient and more complex. So yeah, PowerPC, or actually nowadays RISC-V, PowerPC, but in historic context then PowerPC, Spark MIPS, and others that were there, even certainly Alpha for that matter. And all of those architectures, very good architectures, and actually rather sad, if not depressing, that we don't have them around anymore. Many of them fallen, I would personally say, my personal opinion, due to Intel's marketing money that they could throw with dirty tricks, and also the failed actually Intel Itanium project, as I mentioned earlier, that killed Hewlett-Packard PA RISC as well as SGI MIPS, and in that time frame DEC Alpha. So one part dirty tricks, the other, maybe two, dirty tricks, certainly dirty marketing money, then costs that usually people will rather choose a cheaper implementation, and last but not least compatibility, which is not really that much necessary on servers, but it is just convenient. If you have the same binaries, you can run not only Office, but even at the end the browser. At the end, if an administrator, if a developer cannot run the same binaries on the high-end servers like Itanium or other such SGI MIPS and stuff, at the end, as sad as it is not really that necessary, especially on Linux, but even Windows, you just recompile it and it mostly works except minor porting issues. Also even there at the end, minor porting issues that you could fix in an hour or two or some weeks, of if it's really low-level bugs and trickery. At the end it adds to cost, and which running business does not hate costs. I hope you enjoyed this and learned something. Let's take a very quick look at the peaks, because as usual the summary, some personal story, of course got longer, but yeah, even I did not predict that to take off, and here we are. Let's take a look at the comments. Problem with the RISC-V says there's also strength theoretically, diversity between chips will make things complicated to manage. Not necessarily there is a base either, there are extensions. The only thing is, the only problem I personally see there is drivers and firmware. For me, the annoying thing is not RISC instruction set architecture, but different boot things. That's basically the ARM problem of every board needs different bootloader stuff that kills it for me, but nonetheless it will be highly successful. Further talking about optimization, check out Moscow. Okay, thanks for that. Maybe drop a note in the comments or Discord, otherwise I might forget this. As for getting rid of legacy history, shows that compatibility is critical unless you get really good general x86 ARM RISC-V. Will be a little bit difficult to migrate. On Linux, again, it's not really necessary, right? You just run the same software stack. Even on Windows, I think it's a little bit probably business logic overrated. I personally, with my Linux use for 20 plus years, never really had an issue for that. It's the same X server, it's the same Linux kernel, same core utils, GCC and Emacs or Vim, whatever you fancy. Further comments, RISC-V may have some future in phones, thriving microcontrollers, but don't think RISC will replace x86, thanks so much legacy binary software. In the short term, I agree. In the long term, I expect 10 years plus. I would guess simply due to RISC-V being more modern, more clean, even than ARM. I would think in 10 years it probably takes over ARM, and in 20 years it might displace x86 as well. That is certainly a very long time, and that is also, I agree, normal Windows users will not just switch because of all their gaming or Office or so. For Linux users it doesn't matter at all. I would certainly agree. In microcontrollers you see this already now, the very low cost cents or dollars RISC-V microcontrollers are flooding the market. And then comes this more board computing stuff where we have already similar performance in Raspberry Pis. And yeah, in the future I see no reason, because x86 certainly has huge variable length instruction decoding and scalability issues and other such annoyances. And yeah, so the future, we have seen huge migrations here in very convoluted instruction architecture. I would say the only thing that could stop RISC-V is another open, like different open architecture that has significantly benefits in some way, shape or form. That is my personal prediction. That would be the only thing that could stop RISC-V from taking over everything. Also simply because it's free, which is certainly the Linux or other BSD effect of most servers in the world running Linux or other such open source software. And for the same reason, not only because it's good, but also because it's free, RISC-V in the long term, I expect to take over everything. Further comments, they're good, maybe theoretically designed, but so PowerPC and MIPS peak, at least in regards to available technology, even if only due to throwing money at it. Intel won out. Not sure, wasn't. The benefit of 64-bits that you could address more than 3 gigs of RAM, Windows from consumer perspective. Yes, that is one benefit. Also, right, I could actually summarize that. If you made it so far through the presentation, thanks for the reminder. I actually wanted to mention that. So what are the benefits of 64-bit computing? The benefits are two main benefits. The one benefit is addressing more than 4 GB of memory. Some limit mentions there 3 GB. That is only an implementation detail of x86, usual x86 processors and operating systems. The theoretical limit of x86 is 4 GB. That is the full address range, only that some operating systems used a 1 GB kernel, 3 GB application split for translation, look-aside buffer, flashing. Theoretically, it is not necessary. You could, if you wanted to, with a little bit less efficiency, use nearly the full 4 GB. If you would flush all the TLBs at each context switch. So yeah, that is 4 GB plus minus whatever implementation details, similar details on MIPS. And so yeah, addressing more than 4 GB, although you could do that with physical address space extension, I believe for 36 bits or so since Pentium Pro, but using more than this 3 to 4 GB by an application processor at a time. So that is that was for a long time a minor benefit. The other benefit is also using twice as much data at a time. So for example, for a lot of high performance applications, sync databases or games, it is also processing twice as much data. Especially, you could even with trickery, or not even with trickery, for example, pixel data and so on. So it theoretically can kinda double the throughput for certain applications or like integer heavy applications. Theoretically, right? Of course, the limit is different. There's also for x86 another benefit. x86 had very few general purpose registers. So due to clever re-engineering from AMD, they vastly increased the general purpose registers. So for x86, it is not only more memory, more IPC throughput, or not IPC like data per instruction throughput, it is also more general purpose registers, which also increase performance. So for the that is not the case for PowerPC or the other RISC like PowerPC, MIPS, ARM for the most part. What else do we have? Yeah, all the others basically, because the 32-bit variant already has more general purpose registers. That is a very special x86 CISC, complex instruction set architecture implementation detail. So it is also for normal users more performance. So more performance, even more performance, and even more memory. To summarize that. That answers that probably, and more details. Further comments, Linux OS is not everything. There's plenty of proprietary software out there. Yes, that is true, but that is on the server that nearly disappeared, except strange database software where people are still irritated and by strange, questionable database software from other questionable quality companies. On the server. On the desktop, it might actually change faster than you think with all the mobile craze. So with more, especially the new Millennium generation certain stuff, using more smartphones and tablets and not relying so much on desktop, it could nowadays change even faster, as we have seen also with Apple. So with more people not caring about classic Windows desktop, which I personally have not since 1996, but even the newer generations which are only used to phones and smartphones with all the advantages and disadvantages. So in the future this transitions, as long as you have a browser and then apps, which for Android with Java like bytecode stuff you could recompile, unless you use native NDK, native developer kit stuff. But yeah, in the future this kind of swings could, due to less dominance of Windows these days, accelerate much faster, I would say. Further comments there. George H, 10 years for ARM, 20 for x86, sounds about right. You can already see the strengths of RISC-V from the way Western Digital did their own control SSD switch two-way in order, like Pentium, without a license, as long as it's easier to get an M1 class 8-way out of order RISC-V than ARM. So that's all for this video. Thanks for the questions. Thanks for joining. Don't forget to share, subscribe, maybe membership or Patreon. Have a wonderful day or night, and I hope to see you soon for all the next tech stuff to come next. Okay, one last question. Have you seen Jim Keller's claims performance somewhere more than comparable Intel chip, or somewhere less than Zen 5? I've not seen this. I've seen some Jim Keller stuff. I would need to Google that, so see you then for that future video. But thanks for the note. See you next time.